Awesome. Cool. Welcome to the afternoon talk. For those of you who are very keen-eyed, you probably noticed I am not Kernel. Due to last-minute logistic issues, he couldn't be here. So I do want to put that slide there just so that he gets the credit for the work he has done. Right? That's me. My name's Jack. I work at Bloomberg. And there's a reason for the next three slides. I put the next three slides here. A little bit background on Bloomberg. So we are a financial technology firm. Now, it's great that we're part of this community, part of the foundation. I would imagine some of you fall into the user camp, some of you fall into the developer camp. So I'm here on behalf of Bloomberg not to sell you any product that's built on top of Ceph, because Bloomberg's core business is terminals. Very expensive, unless you're into finance stuff. Wouldn't recommend it, right? But the reason I put this here is because we deal with financial data, and the financial data aggregates up, right? Think about the tick for Google. That data propagates up to a portfolio, to some fund manager's portfolio, and they use for other stuff. So we deal with a lot of data. And narrowing down a little bit, on the storage side, so I manage storage engineering. We have all flavors of technologies that's backing our core business, right? Bloomberg's core business. File, object, block, we have all of them. And between Ceph and vendor-supplied commercial, whether it's software or hardware, we have those as well. We also build our own workflows, et cetera. All that is to say, Ceph is a core technology that supports our business, right? And the business, again, is Bloomberg application, Bloomberg terminal, which I'm not here to sell. So for Ceph, it supports our block, it supports our object. And this is our object setup. Very, very heavily RGW gateway focused. A lot of requests per day. Again, think about in the financial space, a lot of ticks going around, reading, writing. Our setup is fairly big, and because the nature that we're in and the business that we're in, the downtime is extremely critical. Maybe I should word it the other way. The uptime is extremely critical. So the reason I put this slide and the previous two here is I am here as a user group. I'm here to share what we have learned from Bloomberg perspective in order to support a large installation, a high SLO installation. And there's something that we have learned and done that we want to share with the community. All right? So what is the problem that we have discovered and we have, I guess, internalized ourselves and have a solution for? It is that the system, whether it's the service itself or whether it is a physical system, inevitably degrades over time. Now, there's two ways to address this. One is, I'm an engineer myself, so one way is to let's engineer our way out of it, to make sure the system is absolutely perfect, will never have downtime, we can stay indefinitely. That's one way. The other way is quick remediation, right? So that's where the restart comes in. Now, I am not saying they're mutually exclusive. So while we're trying to make sure the system can stay up, the service can stay up as long as possible, there will be times when we have to reboot, restart service. Again, putting the context as Bloomberg in here, we are a regulated entity, which means our hardware, our services has to be on the latest patch. There's no security, firmware has to be on the latest version. So that means we are required to reboot, to restart by the regulators. Now, what is the problem with restarting? You can restart fast, you can restart slow. You guys probably already know the word rolling restart, one of the safer ways, right? Start one at a time or two at a time, move on to the next batch, move on to the next batch, move on to the next batch. Again, for all the previous reasons I mentioned, there are times when we need to roll out a fix really fast. There are times we need to immediately apply a patch into our production environment. And again, our client wants uptime 100% of the time, right? They don't want to drop requests. They don't want latency bursts. So with Ceph, at least up till now, we couldn't do that, right? So again, I'm going to bring back the scale of Bloomberg we're operating at. For a rolling restart with the number of gateways that we have and waiting the appropriate amount of time so that the in-flight request can have sufficient time to process, it takes us 4 hours, 3 to 4 hours, to restart our production one cluster, and we have multiple of them. Okay. So that is the difficulty we're facing. Now I listed some of the other ones. You can read. I'm not going to read off the slide. What else falls short when we have a rolling restart? Right? Operational overhead. You can say, take a look at that second point. You have to mark certain node up, certain node down, take it out of the load balancer. That's human cost coming in. Right? Waiting for a load balancer to drain. There's a time gap, as I mentioned earlier. That is not good for a business such as the financial institution where every tick matters, every data transaction matters. The solution. So, yeah, let me describe. So the text is a little bit slow at the bottom. So the green ones represent your old instance of the gateway. The blue is the new one. So conceptually, you want to start up a new instance so you can take over the handling of the client request while the old instance still remains alive and finish the in-flight request. Conceptually, that's how it would work. Now, this is not yet, I should be very careful with my words, it's not possible up till now, and the reason is, actually, I skipped a slide, so let me take a step back. So this is possible at the kernel level, kernel 3.9 and above, and the 3.9 is not a new kernel. So I believe it's 2013 is when this option came out. So there is a flag where you can reuse the port, right? So as long as the application, the service, the agent, the daemon that we care about can reuse this port, can reuse this flag, it will interact with the kernel in such a way that the new instance of that service, of that daemon, of that agent will start up binding to the same port. Okay? So in this particular case, if you want to dive a little slightly a different analogy, which is the kernel will act as a little mini proxy. So that means if you have multiple instances binding to the same port, of the same service binding to the same port, the kernel will round robin. Again, the requirement is 3.9 or above, right? Which shouldn't be a hard requirement given that it's 2013. So at the high level, this is what it looks like. You launch a new RGW instance. Again, a couple settings you need to tweak, which I will show you. You will bind to the same port, start on the new instance. You will mark the old RGW instance as down, I should say, mark it stop accepting new requests. Not kill it, because then you will drop the in-flight request. You mark it as stopping accepting new requests, so you have time to drain the request. And then a setting, set the graceful exit setting with a particular timeout so that in case it doesn't drain in that period, again, this is based on your particular environment, it will still shut down the old instance, right? So start the new, tell the old to stop accepting the request, and then as a safety, set a graceful shutdown with a timeout so the old instance will die. All right. Again, I'm still talking about the theoretical, right? Theory. I'll show you how this is done later. So what are the wins? It will reduce your downtime 500x. So this happens when you restart, in the current way, when you restart a new gateway, because the way it caches the port, and you have to restart on a different port, that's how the RGW works. From a client perspective, you'll have timeouts, 500s. Your restart windows I described earlier, at the installation that Bloomberg operates, where it's 4 hours to restart the entire cluster for RGWs, this means I can start up new ones while the old one's still processing the request. I can start up as fast as I can. That means that restart window suddenly becomes 0. Well, I guess very short. Okay. And the scaling. So I will talk about scaling later, but at the high level, that means if you're using the same port, that means if tomorrow you have a new workload that coming onto your cluster, that's gateway bounded, start up new gateways. Right? The graph on the right side is what we see in the Bloomberg environment. I know the fonts are a little bit small, but focus on essentially the spikes, right? So the spike represents the amount of 500x error code that our client gets. You can see a huge difference where the blue square corresponds to the spike at the bottom, and the red is minimal. Almost no client impact, right? Again, we rely on the client retry. So if you use S3, there's a retry. So, but the difference is very drastic. All right, so talk about the win. How do we do it? Everybody wants to win. So at the high level, you have to modify the Ceph code. You have to modify the configuration. Now, we use Ansible, so that's Cephconf is specific to our environment. Systemd to allow spawning of new instances dynamically and shutting down them gracefully. And then a graceful timeout for the shutdown. Now, lucky for you folks, I see a lot of you guys here, you guys don't have to do that first step because we've done it. We've sent in a pull request to the upstream, and that has been accepted and merged. And I can go into detail about that one. All right, configuration changes. Hopefully, you guys will agree it's fairly simple. So the focus is on the last part of the reuse port. So make sure that flag is set. I highlighted the 8000. It's to contrast that with previously, if you want to start up a new instance of the gateway, you have to use a different port. Right? So this is possible because we made the code change in the Ceph code base to accept these flags. Consolidated configuration section. So in the Bloomberg environment, we had 3 instances of RGW running on a physical node. So that means our configuration has 3 separate sections, right? The first section starts off on port, 123. Second one starts on port 124. Next one starts on 125. All that can be consolidated to a single one. I pick 8000. And that's it. That's the configuration, right? Again, keeping in mind the scaling comes in, which means if I want to spin up the 4th one, I don't need to modify my configuration. I don't need to deploy a configuration. Very easy, very easy. Systemd changes. Now, the nuance here is that the default systemd setting doesn't follow the start then stop. So remember earlier when I described it in theory, in order to minimize your client's impact to your client, you have to start up the new instance first, tell the old instance not to accept any new requests, then gracefully shut down that one. So the default systemd doesn't follow that sequence. So there's a little bit change here, right? So exec start, exec reload, you need to call a script. Now, I don't know if, how comfortable everyone is with coding or scripting, but it's not that difficult. The script does 3 things. 2 things if you want to eliminate the middle one, right? The first one is basically tells the order, start up the new instance on that same port. If you want, in your environment, you can supply an argument to say this instance will write to a different log, right? That may make it easier for you guys to troubleshoot later on. And then last step is tell the old instance not to accept any new requests. Okay. Scaling. All right, if you want to stop our new instance. So let's say tomorrow there's a client coming in, huge load. You already know your gateway may not be able to handle all that load, so what do? Start up a new instance. How do you make it sticky so that when machine goes through reboot, the setting will still be there, right? In the Bloomberg environment, we're a regulated entity, so the machine will have to go through reboot, as I mentioned earlier, to pick up new patches, updates, firmware. That's the setting you would do. All right, so I crossed out the bottom ones because as I was preparing, trying to modify the words, I actually typed into ChatGPT of how do I overcome this issue that RGW starts on different ports and the client has impact, it lists out the bottom four as sort of the cons, right, or the things that you have to do. And the solution is, write automation to automatically update the BDNS entries, build a database so you can manage the different port tracking, and then if you're a regulated entity, build another database so you can provide that for auditing purposes. As you can tell, modify the configuration file and then the firewall, right, if you start on different ports. On that point, in the Bloomberg environment, again, regulated entity, financial entity, our network setting is default deny, which means anytime you open up a new port, you got to open up firewalls, tickets, and all that. So all of these are not needed if you only use a single port and all your instances bind to the same port. Graceful shutdown. So the settings will apply to, or I guess I should say the parameters apply to the environment if you guys want to adopt this. The settings you guys will have to play around with if you want to adopt this. The general heuristic that we figured out worked out for us, especially for the timeout settings, is the object size divided by the bandwidth. Okay, so the first one is self-explanatory, graceful, turn that on, graceful shutdown. The second one is your fail-safe, right? Even if it could not finish processing the request, let's say request is a super long-running request, you don't want that instance just hanging around. Maybe it's already locked up, so you want to make sure it just, at some point, it exits or it kills. So that second parameter, exit timeout, is a setting that makes sure that will take effect. And then there is a system MD setting. So this is sort of the, I guess, the master switch. Our recommendation is make this setting equal or greater than the timeout seconds. Otherwise, this will take effect first. This will kill your instance before the timeout setting reaches. And to summarize, that is it. So for Bloomberg, we're a high throughput, high usage, mission critical at our scale. So downtime isn't really an option. So if in your institution, if that is the similar case, this may apply to you, right? Makes your operational easier. You don't have to have human on keyboard starting up new instances, spin down instances. It provides a continuous availability. And as I mentioned earlier, this requires two-part changes. One is on the way that you start up the instance and make the settings sticky. The other part is the Ceph code change to accept the port reuse. So that code change is already merged in. When we converse with the community, that change will be in Tentacle. However, if you remember the PR number, the change isn't that big. So if you want to backport to your installation, the section of the code is fairly isolated to the startup. So it will apply if you guys want to backport to your environment as well. Otherwise, the example have been shown. The slides are online. And hopefully, it will make your environment as scalable and less burdensome operationally. Questions? Yeah, absolutely.
Yeah, I was just wondering, one of the other advantages to doing a rolling restart is if you see like one of your health signals start to spike while you're rolling through the upgrades, then you can pause it or halt it. Do you still do that with the new, way you're doing restarts? Like, and if so, are there any particular signals you look at?
Now I have to confess, because at my level, I do a lot of hand wavy, so the folks on the on the ground doing the restart are in the audience. But I want to say the way we do the upgrade, we don't stop the
Just
restart. Is that correct? Once we start the rolling restart, we don't stop.
Historically, when you do the restart, you're shutting down services, which means technically you're reducing your capacity. In this case, the new instances are coming online before the old ones go away. So technically, you're like increasing your capacity before bringing it back to the baseline. So generally, not a concern. The problems might come in, like, as Jack mentioned, like there's things that's hanging out. Let's say you're rolling out a bug fix. and the old instance are in some unhappy state, which is when some of the timeouts and stuff come into play, so it'll eventually clean up, so you don't have to manually do the cleanups. So it'll kill the services eventually if it's like, hey, it's been half an hour, time to go away.
No, I'm just wondering if there was, just in case there was something that went wrong with your automation and it's misconfiguring things, can it catch it? Is there a circuit breaker that can catch it before it replaces all the servers?
So
We don't have an automated way to catch it right now. So during our upgrade, we will have folks. So we build internal dashboards. So we don't maybe take a step back. We don't expose Ceph directly to our internal clients. We wrap it around as a storage product.
Yeah, of course.
So on that storage product, we have different monitoring. We have dashboards. So during the upgrade,
You're still watching all
yeah, we're watching those, and we're also looking at the back end for the folks who know Ceph. They can log on to the box and watching on the back end. So if we do see something that's go wrong, there is no automated way to stop that.
Yeah.
We was forcefully stop.
I was just curious.
Yeah. Other questions? No? Good. Cool. Hopefully you guys learned something today. All right. Thank you.